Yeah, so water resources. In the previous lecture, we talked about the Indus River system and how it flows from the northern mountains to the southern areas of Pakistan and ultimately to the Arabian Sea. Irrigation is a source of water supply. It's an artificial source of water supply, and it's mostly used for areas that don't receive abundant amount of rainfall. So the plants, they rely on these artificial techniques such as irrigation. A lot of areas of Pakistan, including the Punjab plains, they rely on irrigation techniques because even if the rainfall is um, approved enough for the water supply, still irrigation provides excess water for the plant's growth. So if you see that it is very important in arid, semi-arid, and humid areas just to improve yield in our country, 75% of cultivated areas is under irrigation. So yeah, 75% of the farmlands, the agricultural areas are under irrigation. Okay, why do we need irrigation? Let's look at these 8 points. Number one, most of the areas in the country are experience aridity or semi-aridity, which increases from north to south. Aridity, dry climates, less rainfall. So because of in order to counter these dry climates and the lesser rainfall, it is important to provide water to those areas through irrigation. High variability in the distribution of rainfall. It means that at times the areas might experience a great amount of rainfall, and then at times those areas might not experience that same amount of rainfall. Long dry spells, high variability in times of rainfall, small number of rainy days, high rate of evapotranspiration, because Pakistan experiences a lot of sunny days around the year. So because of that, the evapotranspiration increases. And obviously, it also affects the crops because the water for the farmlands would evaporate more quickly and you'll need to replace that water as soon as possible. Okay, and then the water crisis with India, because most of our dams rely on this water that channels all the way from India, and because India has control over these canals that flow from their country, they might stop at any time. This is what they do. This is one of the reasons as to why Pakistan faces water crisis most of the times. Methods of irrigation now. There are two kinds of major techniques of irrigation followed in Pakistan: traditional and modern. This traditional irrigation, it has further 5 types of irrigations: lift, shadoof, charsa, Persian wheel, and guys. These are all the conventional, traditional. Most of these methods are not even used these days. They were just, these methods were used years ago. Yes, Kares is still there in the desert areas, Persian wheels. You might see some of these in villages, but not in the cities. So modern irrigation techniques are the tube wells and the canals. Let's look at the traditional methods of irrigation. Lift irrigation, it is the oldest methods. In early times, water was lifted by hand. Okay, so what happens here is there's you attach a bucket to a rope and you lower that bucket in a well, in a shallow area where the water is collected, and then you lift that bucket up with water. Shadoof is again a bucket suspended by a rope, but on the on one side of the shadoof, that rope is connected to a pole with a rock. The rock basically is a weight that keeps the bucket aligned. The pole is suspended on a Y-shaped post at a well or a river bank. The bucket is dipped into the water by hand, and the weight at the other end of the rope helps to lift it up. So shadoof and lift are pretty similar. You can see here, this is an example of lift. This is what a shadoof is. There's a stone that is connected on one side and a bucket on the other side. You can lower the bucket into water and collect it that way. Charsa is using animal power to lower the bucket and to lift it up again. Okay, the function is again similar to lift and shadoof. Persian wheel, on the other hand, is a little more modernized technique. Still, it is one of the most conventional techniques of irrigation followed. So what happens here is that, so if you see this wheel here, this wheel has all of these buckets connected to it. Each bucket descends, collects water, and brings it back. This is how the wheel works. Okay, so depth of this well should be around 23 to 26 meters. And then there's a Persian wheel attached, which keeps this other wheel moving. Right. So this is again a picture of Persian wheel. Animal power is also used to rotate this wheel in the well. Another Persian wheel. So see how the buckets, they empty the water onto the tray, and then the water is carried to the through the these channels and through the canals to temporary canals to the farmlands. Yeah, now there's this question, an example question, explain how this machine is used for water supply. You can be asked about these methods. Picture descriptions is very important. You might get questions such as um, for example, a picture, and then you might be asked to explain that particular type of irrigation. For the modern methods, there's a tube well. Tube well is basically, I mean, this is one of the modern methods. Tap water is basically operated, it's basically pulled out from the ground through diesel and electric motors. It also lowers the water table and protects the land by waterlogging salinity, because see, this water is being pumped from the land, right? And that water, I mean, that water might arise on the land in the farmlands, and we've studied before as well that one of the problems that these agricultural areas face is salinity. Salinity is when the water stays in the farmland for a longer period of time and it evaporates, it leaves over the minerals and then consequently a white layer on the farmlands. So pupils, when they pull this water out, it is also a solution to these salinity and all of these waterlogging problems. Advantages of tube wells: most efficient, larger area can be irrigated, with regular water supply, cleaner water, reduces waterlogging salinity, and less labor required. Disadvantages of tube wells: it's expensive, its maintenance is difficult, its diesel is expensive, spare parts are expensive, and it reduces the groundwater and lowers the water table. All right. Okay, if you look at these questions now, let's see question number 2. Using examples, explain why there are conflicts over water availability and use. So examples are very important in geography. Conflicts could be between farmers and industries, domestic versus food processing, hydroelectric power versus others. So there could be conflicts on the distribution of water. The industrial sectors might want more water for the industries. The agricultural sectors might want more water for the agricultural areas, right? Similarly, the food processing industries might want water for their areas. So there are conflicts over the distribution, and there are major conflicts between Pakistan and India as well. Since our independence, 1947, there was this water crisis, which was resolved in 1960, and the treaty that was signed in 1960 was known as Indus Water Treaty. And then there have been conflicts between the provinces as well. NWFP, Punjab and Sindh, there has been conflict between these provinces on the distribution of water supply. Okay. All right. These notes have already been uploaded on the Google Drive. You can go through these for revision. And this lecture recording will also be available on Google Drive. Okay. Canal system. It is another modern irrigation method. Canals are basically a man-made pavements, or you could say a transportation technique for this water that takes the water from the source to the farmland. There are two types of major canals: inundation or seasonal canals, or perennial canals. Seasonal canals are basically used to supply water in certain seasons of specific rainfalls, maybe in floods. Okay, these canals are beneficial for kharif crops. Rabi crops take advantage of moisture left in the land from summer flooding. So we're going to come to what kharif and rabi crops are. For now, we just need to know that what inundation and seasonal canals are. Seasonal canals irrigate the active floodplains where the land is sufficiently level and downward slopes from the river banks. The main network of these canals in Sindh and southern Punjab. The Bar upland areas were not served by these canals as they could not rise up to 5 to 7 meters. Okay, so active floodplains we've already studied are the areas that get flooded quite frequently, and they are the areas beside the rivers. So those areas can basically, I mean, those are the perfect areas to build these seasonal canals on, because they get flooded seasonally. Okay, so, and obviously, if you have a lot of canals by a river, you can also divert excess water supply in times of floods. So this is one of the advantages. Disadvantages for these canals are that they don't really supply water throughout the year. They're only used for certain seasons. A single crop is cultivated. They can't really water a larger field. Okay, and they also can't supply water to the upland areas because canals, they channel water naturally through the topography of the land, and we know that the water is easily flowed from a higher area to an area on a lower altitude. So these canals, these seasonal canals, they take water from these higher upper areas to these lower areas quite easily. It'll be difficult to supply water to these upland areas. Okay. Perennial canals are basically these permanent canals that supply water throughout the years, throughout the year, okay? And they can also take the water upland from these dams and barrages. Advantages: supply water throughout the year, both crops are benefited. Okay, Kharif and Rabi, or both the crops are benefited because Kharif and Rabi crops are basically winter and summer crops. All right. So you're going to study this in the agriculture chapter. So meaning thereby that these type of canals can be used in winters as well as in summers. Line canals, these are all the types of perennial canals. Line canals are those that have these cement and brickwork pavements on the sides. Unlined canals are those without these bricks. You can see the pictures here. Disadvantage of unlined canals are that they rise the water table because water can seep into this ground. If you see the sides here, there is no okay, let me just annotate here, guys. If you look at the sides on your screen here, these areas, because they have no pavements, this water can seep into the ground, and when the water seeps into the ground, it increases the water table. Okay, what is water table? It's basically the quantity of water inside the land underground. And when that water table rises, there comes a time when that water, if you look at this here, for example, this is the land, okay? That water will arise to an extent that it will overflow to the land. And when this water from the land evaporates, it will leave behind the salt patches, causing salinity and waterlogging. So see how many problems can be caused by just a single factor that you're not paving the sides of a canal, right? Water table will rise, it will lead to salinity and water logging. Okay, factors leading to development of canal irrigation system in Pakistan. How can you develop the system in Pakistan, and what factors are currently being used to develop the system? Cheap labor availability. Labor is easily available for work. Southward slope of the river makes construction of canals easier because most of the canals, most of the dams that take water from the north side to the southern side, the water is easily flowed because of the direct topography of land. Because Pakistan, if you look at the topography, we have this general slope from the northern side to the southern side, and water flow is easier in that direction. Huge quantities of water from monsoon rainfall and melting of snow can be stored in reservoirs during the summer season. You can use these canals to take water from these rivers to reservoirs and dams, and you can store that water for seasons when the water is deficient or for the generation of electricity and other purposes. Okay. Irregular supply of water in the rivers is then regulated by construction of dams and barrages. Soft soil and level land of Indus Plain makes digging of canal easier than in the rugged lands of Balochistan. Yeah, it's easier to build these canals on Indus Plains because the land is soft, because there's more rainfall, because that Indus Plain is considered as place that is best for crops growth, alluvium soil is available. So yeah, digging is easier. Balochistan, on the other hand, has a rugged landscape with lesser rainfall. It's difficult to construct these canals in Balochistan. Why do we construct these canals? To reduce floods, to avoid wastage of water, and to provide water for irrigation. All right, now this question here is about the effectiveness of conventional methods of irrigation. We just studied the conventional methods such as, Shafa, could you just tell me the names of the conventional methods that we studied? Shafaq, are you there? No? Okay, you're typing something? No, Shafaq, I can't hear you. I can't hear you. You may write it down, okay? So effectiveness of conventional irrigation methods, limited areas irrigated. Yeah, conventional methods, they irrigate limited area. They require manual animal power. They're more time consuming. They're difficult to maintain. For example, carries. Yeah. These are some questions now. Okay, guys, graph analysis questions are very important. If you look at this question here, okay, the question says, in which year was the water supply the highest? So you simply read a graph. You should know how to read these graphs. In which year was the water supply highest? Okay, so if you look at the x-axis here, this is the time period, the years, and this is the amount of rainfall in feet. Okay, in which year was, sorry, water supply? Yeah, in which year was the water supply highest? Yeah, Shafaq, you're right. Tube wells and canals are modern methods. I was talking about conventional methods. Shadoof, lift, carres, these are all the conventional methods, okay? Tube wells and canals are modern irrigation methods. All right. It's all right. It's completely okay. Okay. So if you look at this graph over here, it has this on the y-axis, it has water supply in feet and years on the x-axis. Question is, in which year was the water supply highest? You're going to look at the graph. This is the point where the water supply was the highest. So you're going to look on the axis now. Yeah, so 1999. This is the correct answer. Water supply was the highest in 1999. How much higher was this than the supply in 2002? So you're asked to find the difference between the supply in 2002 and 1999. Let's look at the supply in 2002. See, this is around maybe 80 feet. Okay, let's write it 80 feet. And on the x-axis, yeah, this is 2002. Okay, so 80 feet in 2002 and 110 in 1999. So you're going to subtract this value of 2002 from the value of, from 1999's value. It was 110 and it's 80. So your answer is around 30. Okay, it's around 30 million acre feet. 30 or 31 or 32. The examiners will accept the answers close to this. Okay. Water table, I've already explained what water table, water logging salinity is. Water table is the level of groundwater. Water logging is the rise of the water table to the surface. And salty patches are basically formed. They're known as salinity. Okay. Yeah, that is it. How to reduce these problems of waterlogging salinity? Lining to canals. By lining, you'll avoid the spillage of water on the areas around the canals. Planting the trees in affected areas, because if you plant the trees will absorb water and they'll lower the water table. Okay, this is also very important. I'm going to write these consequences down. So why should you line the canals? Because by lining, what you're doing is you're avoiding spillage of water, avoiding excess water to the surrounding areas. By planting, you're absorbing excess water from the ground. And obviously, when you absorb this excess water, the water table would decrease. Similarly, tube wells pumping excess water to the ground. Educating to improve farmers' awareness. Flushing out of salts by water from tube wells, surface drains. Yeah, it's very important to filter the salt out to reduce salinity. Okay. Government schemes now. How is the government of Pakistan working to manage the irrigation supplies and to obviously control the salinity and these waterlogging issues. SCARP, Salinity Control and Reclamation Project, was launched in 1959. There are a total of different phases for this project. For example, in SCARP 1, Rachna Doab, Faisalabad, Sheikhupura were reclaimed. Government worked in those areas and they reduced this problem salinity. In SCARP 2, the areas around this Chaj Doab, all of these areas were reclaimed. In SCARP 3, Jhang, Muzaffargarh, areas of Sindh were reclaimed, and in last SCARP 4 and 5, Khairpur, Rankuch, all of these other areas of Sindh were also reclaimed. See, this is an example of salinity. It completely destroys the crop. The Indus Water Treaty of 1960, guys. It's very important. This Indus Water Treaty was signed between Pakistan and India because of the water crisis. Pakistan and India had been facing these crises for a long time since the independence. Okay, let's read this now. When Pakistan was created, the province of Punjab was divided. Part of it was given to India and part to Pakistan. The headworks at Madhpur on the river Ravi and Firozpur on the Satluj were in India. Okay, so the headworks of Ravi and Satluj were in India when Punjab was divided. So headworks, it means that the supply of water that comes through those headworks is goes under direct control of India. Okay. And for example, let's say if you have headworks in a certain area and you open those headworks, the water will automatically flow to Pakistan because Pakistan has a lower topography as compared to India. The altitude level of Pakistan is a bit lower. This is why water naturally flows to Pakistan. Okay, so Pakistan is facing serious problems because at times India would just close the headways, at times they would open those without warnings. So closing the headways used to cause water deficiency in Pakistan, and opening without warnings used to cause floods in Pakistan. So Pakistan wanted a permanent solution for this. So in 1960, World Bank agreed that they'll sign a treaty. Indus Water Treaty was signed. Pakistan was given exclusive rights over these three western rivers. Jhelum, Chenab, and Indus were given to Pakistan, and the eastern rivers were given to India. River Ravi, Beas, and Satluj, okay, to India. So India agreed to, they agreed that they'll supply water to Pakistan. And yeah, during this, Pakistan was even given funds to construct these barrages and reservoirs on these parts, so we could also have some storage of water in our country. And yeah, so this is what the Indus Water Treaty was. Dam is a man-made structure built across a river to control the flow of water. They are also known as reservoirs. You store the excess water, and dams are used for the production of hydroelectric power. There are 2 to 3 major types of dams: Tarbela and Mangla Dam in Pakistan. Tarbela Dam was built as part of the Indus Water Treaty, and both of the Tarbela and Mangla were built as part of Indus Water Treaty. Tarbela is about 47 kilometers upstream from Attock. It is a multi-purpose dam. 11 million acre-feet of water is stored and 2.1 million kilowatts of electricity generated via hydroelectric power at Tarbela Dam. Okay, I think this information, you don't need to go further for any more information. That's enough. Mangla Dam was again built in 1969 as part of the Indus Water Treaty. It's located in River Jhelum. It stores 5.5 million acre-feet of water and 3 million kilowatts of electricity is generated via hydroelectric power. And these are the small scale dams of Pakistan: Warsak, Kuramgari, Ghazi Barotha. Okay. Now, the purpose of reservoirs and dams. Number 1, flood control, irrigation, and generation of hydroelectric power. Flood control is very important. When your rivers overflow, you can store this excess water in the dams. Irrigation, that water from the dam can further be used to irrigate the farmlands and for the generation of hydroelectric power. You can also use that land for fishing, for boating, for recreational purposes. It also boosts tourism. Water can also be supplied to nearby towns for domestic purposes. And also, and yeah, that's it. Okay. You can skip this part. These are some questions. We might look at these questions here. Okay, describe the site of the dam. Okay, if you look at the site, it has these steep rocks bare rocks, deep and narrow valleys, gravel and sands, because you need to have these strong edges, strong pavements, and then narrow valleys to have this capacity to store the water as well, right? So this is how, I mean, an area with steep rocks, narrow valleys, barren rocks, and gravel and sand is a perfect site for building a dam. Okay, then there could be questions on comparisons as well. You should know how to understand these pictures. What can be done to stop the amount of water in the reservoir from reducing further? Okay, number one, I mean, evaporation can obviously reduce the amount of water in the dams. Silt traps, afforestation, removal of silt. So if, let's say, these pollutants and eroded materials, they get deposited in a dam, they'll reduce the capacity for water storage. So it's important to keep the dams clean by filtering out these eroded materials and the pollutants. Okay, removal of silt is important. It's also important to reduce the wastage. Barrages. Barrages are similar to dams. They're structures built on a river, and they also store water. They are also used for irrigation. Okay, you should know the names of these important barrages. You don't need to go into the details, just know the names. Chashma Barrage, Rasool Barrage, Marala Barrage, Kadirabad Barrage, Mailsi Barrage. All right, you can just know the names of these barrages. Jinnah, Tanusa, Guddu Barrage. Okay, so all of these, just know 5 to 6 names for the answers, and they'll be enough for you. Purpose of barrages, again, for irrigation, for flood purposes, for inland fishing. Difference between barrage and dam. Okay, barrages are not used for hydroelectric power. Dams are used for hydroelectric power. These barrages can be constructed in flat areas. Dams need to be constructed in the mountainous areas with a, you could say, a rugged topography. Barrages are easy to construct, lesser cost. Dams cost high for construction. Dams are also, they also take 10 to 15 years for construction, because it's a large scale project as compared to these barrages, which might take 1 to 2 years for construction. And with that, we're now moving on these link canals. Okay, link canals are the canals that link other canals. Simple as that. Okay, we studied about the canals a few minutes ago. I was telling you that, for example, if this is water supply and this is your farmland, okay, this is the farmland and this is the source. So canals will take water from the source to the farm. Okay, let's say these are 2 to 3 canals here. Link canals will connect these canals here like this, like this. So these yellow ones are the link canals. You could say sub canals as well, that link these major canals. Okay. Examples: Rasool Kadirabad, Kadirabad Baloki, Baloki Sulaimaninki, Sidhnai and Mailsi. All right, Mailsi and Bahawal, Chashma Jailam, Tonsa and Panchnath. Just know 5 to 6 names again. There'll be more than enough. See, there's a diagram here. This is how the canals link. Major canals here, rivers, and then the canals, and then further linking of those canals. These, all the lines of these arrows are link canals. Okay. Purpose of link canals: to transfer water from one canal to the other, to provide water for the irrigation to the perennial canals, and to compensate for the water lost from eastern rivers. Okay, you can transfer, for example, let's say if the eastern rivers here, Ravi, Satluj, they get less water because the headworks are in India, you can transfer the water from Chenab to this river. Okay, you can transfer water from the neighboring canal to this canal, just so you can compensate with the water loss in times of need, because we still have these conflicts with India over the control of waters. Yeah. All right. Kare system here. Kare system is an underground canal. Okay. It's mostly used to store water in the desert areas and the areas where the chances for evaporation are higher. Okay. So Kares is dotted with vertical shafts which are used to clean and repair it, and in certain areas they're used to extract water for domestic purposes. If the Kares is cleaned and repaired regularly, it can remain productive for a century or more. See, this is how much sustainable a Kares is. The selection of a site for digging the Kares is done by experienced village elders, while the digging and repair is done by a group of laborers trained in this tradition. So it's important to first of all smartly select a site for for these Kares and then build the Kares over there. Kares is usually privately owned by a group of people rather than a single person. Owners share the water according to the percentage share in the Kares. Main problem is that water cannot be stopped from flowing. Furthermore, their maintenance is difficult and expensive. Kares irrigation is practiced in Balochistan, okay, such as Zahob, Lorelei, Quetta, Mustang valleys, Makran, okay. And gradually, Kares are losing the importance because they're getting outdated. So this is how this is a diagram for the Kares. If you look at this point here, this blue this blue horizontal line, this is the Kares, and all of these vertical outlets are where the shafts are inserted and they pull the water out. The advantages of Kares are that the water supply is continuous. Water is put to good use. You can store the water for a longer period of time. Water does not evaporate, and in desert areas, it's the best source for water supply. Disadvantages that it's getting outdated day by day. Government isn't investing in these because of the conventional methods, and Balochistan doesn't experience good amount of rainfall, so it even gets difficult to store water in Kares. Guys, you can ignore the diversion canals. Silaba, you can also ignore that. Groundwater, again, it's pretty, we've already discussed the water table salinity, water logging, and Kares. All of that is a part of groundwater. And with that, we are done with this topic here. Water resources. Please let me know if there's any question, anything that's not clear. I'll go over the topics again if you want me to. The PDF has been uploaded on the drive. You were supposed to attempt the questions for practice.